Study guide for Algebra 1, Unit 7, Polynomials. I know you think you should be on 6, but 6 is a midterm exam that we actually take out. So this unit does say 7 on it. Don't freak out. You actually, your last one will say Unit 11. All right? You only do 10. So starting with problem number 1, they want to know how many terms are in this polynomial. So terms are different letters or numbers, all right? Constants you can add, all right? But there's this term x, y, v, w. You can't combine that with anything. Z, y, v, w. You can't combine that with anything unless it also says z, y, v, w. So that's called a term, all right? So in this expression here, there's 1, 2, 3, 4 different terms. You can always look at your signs. I have 3. That means these are separate. There's 4. And make sure you can't combine any of them. You can't combine anything that are alike. So yes, there's 1, 2, 3, 4 separate terms here. All right, problems number 2 through 4 are adding, addition, and subtraction problems. All right, so problem number 2, it's an addition. It says find the sum of 5n cubed plus 3n squared minus 8 and negative 3n cubed plus 7n minus 5. So I always line these up like a nice addition problem. All right, just like normal. See, the first one says 5n cubed. All right, plus 3n squared and then minus 8. So what you got to do is leave a space here because you're missing your n. All right, but the next problem, it says negative 3n squared, n cubed, plus 7n. So instead of lining that up under n squared, I'm going to put it over here to the side, minus 5. All right, and then we are adding. It says sum, so we're adding. So just remember when you do these, you have to say 5 plus negative 3. All right. Your exponents aren't going to change. You're just combining them. You're not multiplying. Your exponents only change when you're multiplying. So 5 plus negative 3, it actually means minus, okay? So 5 minus 3 is 2n cubed. This one is adding nothing, so it's going to stay exactly the same. Also this one, adding nothing, so it's going to stay the same. And last, we have a negative 8 plus negative 5. So it's actually negative 8 minus 5. So that would be a negative 13, all right? So just remember when you do these, you have to look at the sign in front of each term. So this is 3 plus this, negative 8 plus negative 5. That all matters, so pay close attention to your signs. Number 3 says they want us to correct the difference of negative 3 z to the 7th minus negative 5 z to the 7th. All right, so they're both z to the 7th, so we can combine them. And then remember, this is negative 3 minus negative. So as soon as you say minus negative, that actually means positive. Negative 3 plus 5 is what you're doing here, right? So negative 3 z to the 7th plus 5 z to the 7th. Negative 3 plus 5 is 2z to the 7th, all right? And then problem number 4, it's a subtraction problem. Find 2p squared plus 3p minus 4 less negative 2p squared minus 3p plus 4. All right, so 2p squared, and hold this up here, plus 3p minus 4 less negative 2p squared minus 3p plus 4. All right. So we're going to subtract. Remember subtraction. You have to say what sign's in front of here minus whatever sign's here. So 2, that was weird. 2 minus negative 2. So minus negative, positive. So 2 plus 2 is 4p squared. Then 3 minus negative 3. So minus negative, again, positive. 3 plus 3 is 6p. And then negative 3 minus 4, negative 4 minus 4 is negative 8. Negative 4 minus 4. All right, so remember to watch your signs when you're adding and subtracting. All right, we're going to do one of these expressions. All right, when you have this with multiple set of parentheses, you're going to start with the smallest set of parentheses, all right? If there's a negative in front of parentheses, it's like multiplying by a negative 1. It's going to change the signs of everything inside of it, all right? So we're going to start by removing this one first. We're going to write the whole thing every time, though. So it's going to be A minus B minus C, but here we're going to take it off. So this was a plus D in here, so now it's going to be minus D. This was a minus E, now it's going to be a plus E. And then that F does not change because that's not the parenthesis we're on yet. Okay, then we're going to do it again, removing this set of brackets here. A minus B. All right, we're taking this off. So this was a positive C. Now it's going to be a negative C. It's going to be a plus D minus E plus F. And then minus G is still in these brackets. And then one more time. This is going to change all the signs. So this was a positive B. Now it's negative B. Plus C minus D plus E minus F and plus G. So just remember to change your sign every time. And I know the ones that are tricky are these because they look negative, but this is actually positive. You got to make it a negative here, all right? All right, it's starting with problem number 6. We're working with products now. So now when you multiply polynomials, if you have like variables, as in these two, you have A and A, they're like, and B, their exponents add, all right? So start by multiplying your numbers. This is 1a cubed b squared times 4ab cubed. So 1 times 4 is 4. And then when you multiply your variables, their exponents add. So in this case, you have a to the power of 3. And then here you have a to the power of 1. You never see a 1 up there, but you have to add the 1. And here you have b squared and b to the 3rd. So you're just going to add those numbers. So it's going to be 4a to the 4th and b to the 5th. All right, so remember, you'll never see a 1, but you have to add it. All right, so now move on to number 7. Number 7 says negative 2x to the power of a times negative 4x to the power of b minus 2x to the power of 3 plus 5x. All right, so this is a multiplication problem. We'll have to do distributive property here. It's a monomial multiplied by a trinomial. It has 3 terms, so we're going to multiply this by each term, one at a time, all right? So the first term is negative 2x to the power of a times negative 4x to the power of b. And so negative 2 times negative 4 is actually a positive 8. And then it's going to be x to the power of a and plus b, right? Second, we're going to do negative 2a to the power x to the power of a times negative 2x to the power of 3. So 2 negatives, again, a positive 4. X to the power of a plus 3. And last, we have negative 2x to the power of a times 5x. So negative 2 times 5 is negative 10. And then this is going to be x to the power of a plus 1. We don't see the 1, remember, but we do have to add the 1 whether we see it or not. All right, on problem number 8, we're going to multiply a trinomial times a binomial. Now, if it was, we'll get to it in a minute, but when you multiply binomials times binomials, you can use FOIL method. But this isn't that. This is a trinomial times a binomial. So when I do these, I like to make a little box. So we're going to say x squared plus 4x plus 8. And here we're going to put a 2x and the negative 1. All right, and then you just multiply each one. So 2x times x squared would give you a 2. 2 times 1 is 2, and then 1 and 2 would give you x to the 3rd. Second here, it's going to be a 2x times 4x is 8x squared. And last, the 2x times 8 is a 16x. Then bottom, times the negative 1 is going to give you a negative x squared, negative 4x, and a negative 8. Now when you start this, this is going to be your first answer right here, 2x cubed then these two should combine. 8x squared minus x squared. So 8 minus 1 is 7x squared. 16x minus 4x is a positive. 16 minus 4 is 12x. And then the minus 8 goes last. All right? Draw one of those boxes if you need to. It's a simple way to do these problems. Number 9, we're going to start with dividing. They say find the quotient. So the same thing as multiplication, except for rather than your exponents adding, they subtract. All right, so multiply your numbers first. 48 divided by 3 is actually 16. All right, and then you have a to the power of 3 minus this 1, b to the power of 1 here, minus 1, and c to the power of 2 minus 1. So that's going to leave with the 16a to the power of 2. These cancel, so the b's gone, and then 1c, because 2 minus 1 is 1. All right, problem number 10, they do a trinomial divided by a binomial, a monomial. So it's just 35 in cubed minus 30 in squared plus 25 in, and they want this divided by -5 in. All right, so when you have a trinomial divided by a monomial, you just got to divide each term by -5 in, all right? So you're going to do this one first, 35 in cubed divided by -5 in, so -7, right? And in cubed, and you're going to minus the 1. All right, -30 divided by -5 is actually +6, and that's going to be in 2 minus 1. And then last is a +25 divided by -5, which gives you a -5 in, and it's going to be 1 minus 1. All right, so it should be 3 minus 1 is 2, and you don't have to write this out. If you can do it in your head, you can do it in the first step. That's absolutely fine with me. 2 minus 1 is 1, and then this one cancels completely. So it'd be -7 in squared plus 6 in minus 5. All right, numbers 11. We'll skip over 12 for a minute and then do 13 after we do this one. We got a division problem. We have a trinomial divided by a binomial. Now, when you start dividing by binomials, you have to do it with long division, all right? So we're going to try out our long division skills. All right, so c squared plus 2c minus 35 divided by c minus 5, right? So first thing you got to do is you got to make this one match the first term. So what do I have to times c by to make c squared? So just c times c is c squared. Once I've done that, I have to multiply this term by the second term in the binomial. So c times -5 is -5c, and subtract. These are going to eliminate. 2 minus -5, so actually means 2 plus 5, is 7c, and then drop the -35. Now what do I have to times c by to make it equal 7c? Just a 7. 7 times c is 7c, and 7 times -5 is -35, and those both eliminate because they have the same sign, 0. So the answer would be c plus 7. Now problem number 13, it's also a long division problem, and it just says w to the power of 3 plus 64 divided by 4 plus w. Now when you have this, you got to put in placeholders, all right? So you have w cubed. You have to have all your descending powers for division. So this should be cubed. So if you just have one of them or you're missing one, you have to put in placeholders. So here we're going to put a 0w squared plus 0w, and then we can put the 64. So if you have 3, you have to have 2 and 1. And you got to divide this by, it says 4 plus w, but we need the w first. So we're just going to switch it around to w plus 4. All right, so what do I have to times w by to get w cubed? I have to multiply it by w squared. W squared times w is w cubed. W squared times 4 is 4w squared. And then subtract. These eliminate. 0 minus 4 is -4. W squared. drop the 0w. What do I have to times w by to get negative 4w squared? So I need a negative 4 and I need one more w, negative 4w. Negative 4w times w is negative 4w squared. Negative 4w times 4 is negative 16w. Subtract, these eliminate. This is going to be 0 minus negative 16. Actually makes a positive 16w plus 64. Now what do I have to times w by to get 16w? That's right, just a 16. So 16 times w is 16w, and 16 times 4, would you believe it, is 64. And those are both going to eliminate. And your answer is going to be w squared minus 4w plus 16. All right, number 12, we have to, they want to simplify, so you got to multiply. So you'll do your distributive property. 8y times y is 8y squared. 8y times negative 4, and a positive and a negative make a negative 32y. Then 3y times y is 3y squared. 3y times 2 is 6y. And then combine your like terms. 8y squared plus 3y squared is 11y squared. And negative 32y plus 6y is a negative 26y. All right, problem number 14. They want to identify the greatest common factor of negative 10c squared d and 15c d squared. So remember, the greatest common factor is the biggest number that goes into both of these. This one's pretty simple. It's going to be 5. All right, and then with your exponents, you remember it's the smallest exponent you have for each variable, because there's one c to the power of 1 or 2. So what's in both of them? They both have at least 1. This one has 2, but that one doesn't. So 5 is the number, and then only one c and one d. So the greatest common factor would be 5cd. All right, problem number 15, they want you to multiply some binomials. So they want 2p plus 7 times 3p minus 9. All right, so when we multiply binomials, we use the FOIL method. So first, outer, inner, and last, all right? So your first terms are these two terms. 2p times 3p is 6p squared. And then outside terms, 2p times a negative 9. So a positive times a negative is a negative 18p. Inner is 7 times 3p, 2 positives, positive 21p. And last, 7 times negative 9. So negative and positive, negative 7 times 9 is 63. And then you can combine your two middle terms. Negative 18p plus 21 gives you a positive 3p. So 6p squared plus 3p minus 63. That is how you multiply binomials. All right, number 16, we get to the fun stuff, the factoring. All right, so 16 and 17 are actually more simple because they don't have a coefficient on your first term. When you don't have to have a coefficient on your first term, you don't have to worry about its factors, all right? Because the factors of y squared are always going to be just 1 and 1, y and y, all right? So we take our factors of the last number and see which one of them are going to add or subtract to make the middle number. All right, so 6, we have 1 and 6, 2 and 3. Actually, because this is positive, we can't subtract. We have to see which one of these is going to add to the middle number. So 6 plus 1 would be 7, 2 plus 3 is 5. So we got to use 2 and 3. 2 and 3, it doesn't matter which order, and then because it's positive, it's going to be plus, plus. All right? Same thing here at the bottom. P and P are going to be our first terms. All right, but our factors of 32 are 1 and 32, 2 and 16, 4 and 8, and I think that's it. All right, so which one of these are going to add to make the middle term, which is 18? So 33, right here, 16 and 2. So we're going to put a 2, 16. Again, it doesn't matter which order. And because it's plus, plus, we're still going to have a positive and a positive. Number 18. So this one's a little bit harder because now we have a coefficient on the first term. So we actually have to take our factors of this number and this number and combine them to make the middle number, which is 17. So we're going to start with this one. We have our factors of 8 are 1 and 8, 2 and 4, and our factors of 2 are 1 and 2. So it makes it pretty simple. But we have to multiply one term by one, the other by the other, and then add them. Because it's plus plus, it's going to be added. So say the bottom, we could go 4 times 2 is 8, and 2 times 1 is 2. 8 plus 2 is 10. That doesn't give us 17. We could go the other way. You go 2 times 2 is 4, and 4 times 1 is 4. 4 plus 4 is 8. That still doesn't work. So let's try the top. 2 times 8 is 16, and 1 times 1 is 1. 16 plus 1 is 17. That was the number we were looking for, right? 17. So that means we're going to use this one and this one, all right? So these are our first terms. So write your 2 sets of parentheses. Our first terms are going to be an 8y and a 1y. And then what did I want to multiply the 8 by? I wanted to multiply it by 2 to get 16, right? So it's got to go all the way out here. So the outer, I get 16, and then inner, the 1 goes here. And because it's plus plus, it's positive, positive. Watch where you put your second factors. If I had put the 2 here, it wouldn't work because these 2 never multiply in FOIL. It has to go across from it or in the middle so that it multiplies by each other. All right, in problems number 19 and 20, we have what are called special cases. So when you get a trinomial, you need to look and see if your first term and your last term are perfect square roots. Remember, your perfect square root numbers are 1, 4, 9, 16, 25, 36, and 49 for now. All right, so yes, these are perfect square numbers. They both have a square root. So when that happens, you can just take the square root of this one and put it here, and the square root of that one and put it there. And then if it's plus plus, it's just going to have a plus, and it's twice. Instead of writing it x plus 1, 5x plus 1 and 5x plus 1, we just say it's 5x plus 1 squared. All right, this one, you can see the middle term is missing. That means it's called the difference of 2 squares. This has a square root 16, this has a square root of 5, but the middle term is missing. So when that happens, that means these 2 binomials matched exactly, except for one is positive and one is negative. So the square root of 16b squared is 4b. It goes here and here. And the square root of 25 is 5. And then one has to be positive and one has to be negative. And you're done. Watch out for those special cases. Check for square roots before you start. Problem number 21 is a 4-term or a quadrinomial, 4-term polynomial. And in this case, they want you to factor by grouping, all right? These are actually my least favorite. Don't judge me. I don't really care for factoring by grouping. Okay, but to factor by grouping, you gotta put the like terms together. So we'll put the p's together and we'll put the q's together, okay? Mind your p's and q's, all right? I'm sorry, we'll put the q's together and the r's together. P's and the r's. It doesn't matter, really. We'll put the p's together and the 3's together, all right? So we're gonna put, actually we're gonna put p, q, because these two aren't like, we'll put this 3q over here. So minus 3q. All right, and then we'll leave these two r's together. We'll say PR minus 3r. All right. So here we're going to take out a q. So take out the q, we're left with p minus 3. And on this one, we'll take out the r's, and so we'll left with p minus 3. So when you do this, these two should match. That's one term. One term should be p minus 3. And then the other one should be these two terms, q plus r, all right? Problem number 22, they say factor completely, all right? So they gave you a little clue that this one you need to check to make sure that there's not a common factor. There is in 5, 10, and 40. 5 goes into 5, 10, and 40. So before you start, you need to factor out a 5. Take the 5 out. That will leave you with just an x squared plus 2x and then minus 8, because 40 divided by 5 is 8. So when you do this now, this makes it very simple to factor because there's no coefficient right here. It's just going to be x and x, remember? And then our factors of 8 that add or subtract to make 2 are going to be 4 and 2. And then this one you see there's a positive and a negative. So one of these has to be negative, but our middle term is positive. So that means our bigger number is positive, and we want to subtract the smaller. So we'll leave the 5 right there. That's called factoring completely. We need to do the same thing on problem number 23. I'll just write it out real quick. Problem number 23, they gave you this problem. Negative 2bk cubed plus 6bk squared. It's 2bk squared, 6bk, and 3, should have written it out before, minus 2b. All right, this one, they want you to factor completely. Well, if you look, 2, 6, and 2 are all divisible by 2, but also there's a k in each expression. So we're going to take out negative 2, so we can get rid of this negative b. So we're going to factor out a negative 2b. So all we have left here, we took out negative 2b, we have a k squared. 6 divided by negative 2 is negative 3k, because we took out the b. And then negative 2b divided by negative 2b is plus 1. Now in this case, these do have a square root, but this isn't the middle term. So this is prime. You can't factor this any lower. So that's actually the final answer on that problem. All right, problem number 24 says 360t plus 10t cubed minus 120t squared. And they want you to factor this completely. So this problem, number one, before you ever start factoring, you want to put them in the correct descending powers. So in descending powers, the 10t cubed would go first, and then the 120t squared, and then plus 360t. Now, all of these terms, there is a greatest common factor. 10 goes into all of these, and also there's one t in every term that can be taken out. So we're going to take out a 10 and one t. So we took out the 10 and then one of those t's, so it should just be t squared. 120 divided by 10 is 12, and we took out one of the t's, so now it's just t. And 360 divided by 10 is 36, and we took out that t. So now we have 10t and then t squared minus 12t plus 36. Now we have a perfect square. T squared has a square root of t, 36 has a square root of 6, and it's minus plus, which means they both were minus, and there would be 2 of them. And don't forget this 10t in front. Problem number 25, they want you to completely factor a 4-term polynomial. All right, so we'll have to do by grouping again. This one says negative x squared y squared plus x to the 4th plus 9y squared minus 9x squared. I've rearranged it already. I put my x in descending powers of x. Okay, so when you do that, you put your highest number of x and then anything combined and then less. So x to the fourth minus 9x squared minus x squared y squared and then plus 9y squared. Now we're going to group these two and these two. All right, so in this term we are going to take out an x squared. So if you take out x squared, what you have left in here is x squared and a minus 9. And this one we have a negative x squared, y squared, and a plus 9y squared. So we're going to take out a y squared. We're actually going to take out a negative y squared. So that'll change the sign. So we're going to take out a negative y squared. Here we'll leave an x squared and change this to a minus 9. So now x squared minus 9 and x squared minus 9, they match. That's one of our terms. And then the other one are these two terms, x squared minus y squared. Now both of these are perfect squares. They're actually the difference of two squares. So remember, in the difference of two squares, you have two binomials that match except for one's positive and one's negative. So the square root of x squared is x, and the square root of 9 is 3. So x plus 3 and x minus 3. And this one would be x plus y and x minus y. All right? All right, do good. Practice up on your factoring, and you should do fantastic on this test.